So, hello everyone. My name is Sajan Kumar. So, I basically working as a battery pack design engineer in the industry, and I'm having more than eight plus years of experience in this field. So, today I will be delivering you the basic introduction of electric vehicle. So, today we will be basically giving you a basic introduction of electric vehicle, and then mainly we will be focusing on the battery pack design of electric vehicle. Okay, so more and less everyone know about what is electric vehicle and how it works and all. So we will put up a little light on that, and then we proceed hardcore on this battery pack design, how we design a battery pack in for the electric vehicle application or for ESS application. ESS means energy storage application. Okay, so let me share my screen first. Just a moment. Sonu sir, I'm not a host, so I'm not able to share my screen. Okay, got this. Okay, so my screen is visual to everyone, correct?
Yeah.
Okay, okay, thanks for confirming. So as I told you, basically we will be talking about the battery pack design of electric vehicle. So first of all, like I welcome you all to this boot camp, and I'm very thankful to you all. Like you gather this time to be here. Okay, so let's proceed further. Okay, so what topics we will be covering today? Today we will cover introduction to electric vehicle and their major components, what major components are there, and then introduction to electric vehicle battery pack. Then we will be having few battery pack calculations, and then we will be going further battery pack design. Okay, so this four things, four topics we will be covering today. If I say you, if I ask you, what is an electric vehicle, then we can say an electric vehicle is a vehicle powered by one or more electric motors using electricity stored in rechargeable batteries, offering a greener and more sustainable transportation option, which is manufactured for use on public roads. So here is a point which is manufactured for use on public roads. So we have, like, for in case our country in India, we have Indian Railways, right? They also runs on electricity, but they don't comes in electric vehicle category because they don't fulfill few requirements of this, like they don't have, this rechargeable batteries inside them, right? They are having a continuous power supply. Secondly, they are not manufactured to use on public roads, right? They are having a specified, a specialized tracks are there on which only they runs, right? So that's why electric vehicles are the vehicle which are having, which are having I will request participants to mute yourself, please. Whenever there is a conversation required, I will ask you all to, unmute. But when I am delivering this thing, please mute yourself. Sonu sir, I will request you to keep track on that. Thank you. Sandeep Sharma, please.
भाई स्टिल होते ना बाबू साहब
Okay, sorry for the disturbance. So these all are vehicles which are manufactured to use on public roads. Okay. So major components of an electric vehicle. Whenever we talk about an electric vehicle, then we will talking about pure electric vehicle or all electric vehicle. Okay. So there are various categories of electric vehicles. So whenever we will be discussing about this electric vehicle, then I mean all electric vehicle or pure electric vehicle. In pure electric vehicle, we have few major components, right? And what are these major components? I will be telling about those also. Okay. So first major component we are having traction battery pack. Okay. This traction battery serves as a energy storage for that, and it supply the energy to the vehicle for running onto the road. We have charging ports. So battery needs to be charged, right? So we have the charging port which is connected to onboard charger. So onboard charger is also there on your vehicle. In two-wheelers and all, onboard chargers are not there. They are having a transportable, or we can say mobile chargers is there. But mostly on four-wheeler, each and every four-wheeler is having a separate onboard charger. We have transmission system, and then we have a auxiliary battery. Auxiliary battery is for, the lights and all, like whatever apart from motor, whatever other accessories are there, they also need some electricity. But since they runs on lower voltage system like 12-volt system, so there is a auxiliary battery for that. So which also gets charged and charged from this main traction battery, and then it supply the power to other components. We have a thermal systems. In electric vehicle, many of you might heard about that ki electric vehicle catches the fire and all. Why this is happening? Because proper thermal management is not there. When you other other parameters are also there, but major parameters for you know this fire and all in the electric vehicles are because of not a proper thermal management system. So you would be having a thermal system, cooling system, and heating system in your electric vehicle. Then we have a DC-DC converter. What this DC to DC converter do? So as I told you, all the lower voltage components, the auxiliary battery, those all are runs on lower voltage DC systems, right? And the main traction battery are on higher voltage DC system. So we need a DC to DC converter which converts that higher voltage to lower voltage, okay, for the auxiliary component and to charge the auxiliary battery. Okay, we have a power electronics controllers are there. Okay, so these power electronics controllers used to control all the vehicle electronics. And we have a BMS also, that is a part of the battery pack. And we have a electric traction motor. What these traction motors do? In place of engine, like for example in a IC engine, we have a engine, right? In electric vehicle, in place of engine, we have a motor. So that's why we called a traction motor, because it help us to track onto the road. It help us to run onto the road. So this sometimes we call this motor as a electric traction motor as well. Okay. So these are the major components of this electric vehicle. We will be talking about these components some more detail in our upcoming slides. Okay. Cost and savings. So I will, if I speak you like why electric vehicles are required. Okay. Why electric vehicles are required. So, two, three major parameters are there. First, like pollution. So we can see the IC engine emits lot of pollution, right? They are having a tailpipe, and from that tailpipe, CO2, COX, lot of this, emission gases are there, which is not good for our health, which is not good for our environment. Okay. So first thing is this. If we use the electric vehicle, then at least tailpipes are not there, right? So since tailpipes are not there, so they emit lesser pollution compared to compared to conventional IC engine vehicles. Okay. Now some of the people will be telling me ki, in IC engine we have a emission tailpipe. In electric vehicle also we need electricity to charge this, right? Obviously we need an electricity to charge the your battery pack and all, and that electricity comes from power grid, right? But what is happening here? There is a term called well to wheel efficiency. Okay, so once you compare these two, IC engine and electric vehicle, we will come to know the in IC engine, the efficiency, the from well means from where we get the fuel like petrol and diesel, then refining and all, then going to your fuel tank, then conversion efficiency of power from fuel tank to engine, and then engine to your wheel. So that if you compare this efficiency, and in case of electric vehicle, we have a fossil fuel, then we convert them into electricity in our power plants and all, and then from transmission line it comes to our grid, and then from grid to we take it to battery pack to charge this via a charger. And then if you compare these two efficiency, the electric vehicle efficiency is far better than the IC engine vehicles. Okay, so this one thing is there. Then second is cost and savings. So whenever we talk about cost of the electric vehicle, we know now in present scenario, the electric vehicle costs are higher, way higher. They are higher than the IC engine cost. Just for example, if you go for Tata Altroz, for example, if it comes in 8 lakhs, then the electric version of that will be coming around 14 to 15 lakhs. So this much of cost difference is there, right? So people always hesitate ki, oh, this electric vehicle is this much costly. No, itna costly hai. Then why to buy this, right? Then second thing comes is savings on running cost. So the running cost of electric vehicles are way lower than the IC engine. Okay, for example, suppose you are daily commuting 60 kilometer per a day. Okay, so for 60 kilometer a day, and if your vehicle is giving a mileage of 20 kilometer per hour, then 3 liters of petrol you require, that means 300 rupees per day, right? For 300 per day for electric vehicle, it will be hardly required 15 to 20 rupees. Okay, so this much of running cost difference is there. Okay, and due to that lower running cost, the electric vehicles are way good compared to IC engines. Okay, if you think in long term, like 5 years plan, 6 years, 10 years, if you think in long term, the electric vehicles are the better choice, better option compared to IC engines. Okay, clear everyone?
Yes.
Okay.
Yes, Ji.
Okay. So let's moving forward. Apart from this running cost, we have few other benefits in compared to electric vehicle. So in electric vehicle, we have purchase incentives. So whenever you go to buy a electric vehicle, the government gives you an extra incentives, okay, for this electric vehicle application. Second, fuel cost saving, already I speak about this. Maintenance and operational expenses. Okay, so in IC engine, there are too many moving parts are there. There are too many moving, in engines itself, we have piston, we have cylinder, we have crankshaft, we have flywheel, we have connecting dots. Lot of moving components are there. And whenever there is as many moving components, the wear and tear chances are high. Correct? More the numbers of moving components, more the numbers of chances of wear and tear will be there. In electric vehicle, only one motor is a moving part. Okay, and that's why their wear and tear chances are very less, and that's why maintenance and operational expenses are very less in electric vehicle as compared to IC engine vehicle. Apart from this, you also get this, what we can say, tax benefit. Whenever you buy a electric vehicle, you can get a tax benefit for the same. Okay, tax benefits are also there if you are purchasing an electric vehicle. Okay, moving forward. Types of electric vehicle. So just a few slides earlier, I was talking about full electric vehicle or battery electric vehicle. So what is full electric vehicle or battery electric vehicle? So this is battery electric vehicle. In this one, only electric vehicle systems would be there. Okay. Only electric vehicle systems are there. But when we comes to other electric vehicle options, like type of electric vehicle, we have hybrid electric vehicle, and then we have plug-in hybrid electric vehicle. Okay, so if I talks about types of electric vehicle, so majorly we have three types of electric vehicle: battery electric vehicle, hybrid electric vehicle, and plug-in hybrid electric vehicle. So in battery electric vehicle, I already told you ki these all are major components. Like this is a battery electric vehicle system. We have a this traction battery pack, charging port, transmission systems are there, onboard charger, auxiliary battery, thermal systems, DC to DC converter, power electronics controller, and electric traction battery are there. In this case, there is no IC engine systems are there, correct? There is no IC engine system. But when we talks about hybrid electric vehicle, we have combination of IC engine and electric vehicle, and that's why it calls hybrid electric vehicle. Hybrid means combination of two, right? Mixture of two. That's called hybrid. So in here also the combination of electric vehicle system and the combination of IC engine system is called hybrid electric vehicle. So in this what happened? Majorly you will be running on IC engine systems, but the electric vehicle system will be supporting you. Okay, the electric vehicle system will be supporting the IC engine whenever required. For example, if you are, you know, climbing on a hill, climbing on a flyover, or if you require high power in any situation, for example, you have to take a race, you have to drag your vehicle, you have to speed up your vehicle. In those all scenario, in those all situation, in with IC engine system, parallelly, the electric vehicle system will be giving assisting power. Okay. So in this, the battery packs on all are used to be a small. Okay, there's a small battery pack there. There's a small motor is there, and those all systems, you know, uh, gives you a additional power to run your vehicle, and that's called hybrid electric vehicle. In this one, you don't have any option to charge your vehicle. Okay, in this one you don't have any option to charge your vehicle. But in plug-in hybrid electric vehicle, it is just similar to electric vehicle. It's just similar to hybrid electric vehicle, but additionally you can charge your battery pack from external storage. Okay, external source. In hybrid electric vehicle, what is happening? Whenever you takes a break, okay, at that time, this in IC engine, what happen? Whenever you take a break, then what will happen? All the kinetic energy of the vehicle get converted into heat energy, and it's useless, right? You are not able to use that. But when we talks about hybrid electric vehicle, we have a regenerative braking system. Okay, and what this regenerative braking system do? So in same motor, when when you are accelerating, the motor acts as a motor. When you takes a break, when you takes a break, see, I will request you participants to not do anything on the screen. You are like doing a sketching and all on the screen. Please don't do this. Okay. So where I was. So in hybrid electric vehicle, what is happening? So there is a regenerative braking system. So whenever you take a brake, that time the motor acts as a generator. We have some power electronics and all. So that power electronics can switch, switch on from this motor phase to it converts themselves from motor to this generator. And when you takes the brake, that brake supply the rotational force to the generator, and that generator generates some electricity, and that electricity is to charge your battery pack. That's why that is the way hybrid electric vehicle works. That is the way the battery of the hybrid electric vehicle get used to get charged. In plug-in hybrid electric vehicle, what is to happen, the same thing is there. Additionally, you can charge the battery pack from external power sources, and that's why in plug-in hybrid electric vehicle, the battery packs are slightly bigger than compared to hybrid electric vehicle. And in plug-in hybrid electric vehicle, you can run, like you can fulfill your daily requirement, like you have to go daily to your office or to your school, to your college. Those all daily commute requirement you can fulfill by your electric vehicle system in plug-in hybrid electric vehicle. And whenever you have to go on a long run, okay, since the battery pack is not as big as pure electric vehicle, so whenever you have to go on a long run, then you can switch to IC engine system once your battery get complete discharge. Okay, so this is the three major difference between the battery electric vehicle, the hybrid electric vehicle, and plug-in hybrid electric vehicle. Clear to everyone?
Yes, sir. Uh,
Okay, thank you.
Yes, Ji.
So now, as I told you, we will be more focusing on the battery pack design of the electric vehicle. So here we have this thing, a battery pack of a normal electric vehicle. Okay, so you can see there is a major components of there. So we have battery modules. First of all, the major component of the battery pack is a battery module. Okay, I will tell you what is the battery modules and all are there. So I will be telling you in next slide. So we have battery modules, then we have cell. Okay, we have some tray, you can say it as a tray, or you can say as a tub. So in that we keeps all our batteries, we keeps all our modules, right? So that is cell. Then we have water cooling system beneath that. In bottom side we have the water cooling system. We have a underbody shield, because the in electric vehicle, especially in car, in electric car, what is the what happening, the complete battery pack is placed in bottom of the vehicle. Okay, the complete battery pack is placed in bottom of the vehicle. So we need a underbody protection, underbody shield we required. Like you are running onto the road, sometimes the stones and all can come to your bottom body of the vehicle. The water and all could be injected. So too many things could be happen. That's why in bottom there is a underbody shield, or you can say underbody protections are there. Then we have a crash protection frame in any vehicle. Nowadays there is a term called NCAP, right? This global this crash testing agency there. So Bharat NCAP has been started. You all aware about this? So in NCAP, what we do a test, crash test, right? And see how safe this vehicle is. So at least this vehicle should be safe. So batteries are very sensitive. If your battery is not, safeguard, then anything could be happen. Fire could be happen. This to safeguard these all things, a crash protection frame is there. Then we have a skeleton in which we keeps in between which we keeps different modules, and we have a cover. Okay, so you can see so these all components are there. These all are battery modules. Then we have this diaphragm cell. These all you can say as a tub in which these all will be keeping up. And between these modules, we have a skeleton, right? To give extra strength to the battery pack. We have a top cover to cover this. We have a underbody protection, right? And a crash protection frame is there. Apart from that, there is a water cooling system which is going inside to cools down the battery. And not only cools down the battery, whenever we require some heating of the battery, at that time it heats up the battery as well. Okay. So this is a basic battery pack which looks like this. Clear, everyone?
Sajanji,
Yes, yes,
you were talking about the four-wheeler battery pack, right?
yes. Today, majorly we are talking about four-wheeler battery pack.
Okay, fine.
Okay. So now in battery pack, whenever we have to design a battery pack for a electric vehicle application, we talks about batteries. Okay, so we need batteries to run your vehicle. And what is battery? A combination of cells are called battery, right? uh, Batteries are plural form of cells. So whenever we have to design a battery, we need a cell, right? And whenever we have a choice of cell, we talks about lithium ion batteries, lithium ion cells, right? We have other chemistries as well in the industry. We have lead acid cells, we have lead acid batteries, we have nickel cadmium batteries. Enormous, composition or chemistries of the batteries are available. But we use lithium ion batteries in all of them because of their high energy density. There are lower rate of self discharge, their cell voltage, load characteristics, and no requirement of priming, and variety of types available. Okay, and what all these are? Okay, so high energy density. First point is our high energy density. So whenever we have to design a battery pack, so first how we start? Okay, so first we need to choose a cell. Correct. Whenever we have to design a battery pack, first thing, foremost thing, we have to choose a cell. And what speciality should be there in that cell? What additional point should be there in that cell? That is first point is there, high energy density. We will be choosing that chemistry which will be having highest of the energy density. And till now, in present scenario, all the available chemistries are there. In those all chemistries, lithium ion chemistry, lithium ion cells are having highest energy density. Okay, what is mean by highest energy density? So in each and every cell, some energy would be there. For example, uh, I hope you all remember, in our childhood we have a torch, right? We have a torch, and in that torch we have some two or three cells we used to keep. Correct? You remember all? So in that, if cell is a pencil cell, suppose there is a this a small torch, then what will be happening? There is a small pencil cell will be there. So that will be having lesser energy, and that run, for example, that runs 1 month. After 1 month, you have to change your battery. But when you have a big torch, and in that 3 4 cells are there, or a big cell are there, then you can run on 2 3 months. Correct? Why this difference is there? Because that cell is having higher energy. Okay, and what is energy density? So energy density means per kilogram of weight, how much energy is there. Okay, for example, a cell is having 1 kg of weight, okay, or 500 gram of weight, or 250 gram of weight. So in 1 kg of that cell, how much energy is there? And that's called energy density. Okay, clear, everyone? Just for example, suppose in your mobile phone, this 500 Ah cell are there, for example. Okay, 500 Ah cell are there. Then what will be the energy in that cell? So 500 mAh is there, so it will be 5 Ah. Correct? Hello,
Yeah, Ji.
I'm audible to everyone.
Yes.
Yeah. So what is happening in your mobile phone? You have someone is having 3500 mAh, someone is having 4000 mAh, someone is having 5000 mAh. So I'm just taking an example, 5000 mAh, milliamperes hour. Okay. The SI unit is AH, ampere hour. Okay. So 5000 mAh means 5 Ah. So 5 Ah means 5 Ah into 3.2 volt. These cells are generally 3.22 volt. So 16 16 this watt hour is the energy of that cell. How? 5 into 3.2, that is 16. So that much of watt hour is there in that cell. Okay. 16, 5 into 3.2 equals 16. Now, if I divide 16 by 1000, okay, that will gives me the energy density. Okay. So this energy density is 0.016 watt hour per kg. Clear, everyone? Just I will open my notepad and show you how it is happening, or in calculator itself it could happen. Okay. Okay. So what I was telling, the 5000 mAh. 5000 mAh means 5 Ah. Okay. So 5 into 5 is the Ah of that battery pack into 3.2 volt. If I multiply the energy capacity, sorry, the current capacity into the voltage, then it will give me the energy capacity. Okay. So 5 into 3.2, 16 watt hour is the energy of that cell. Okay. If you are having a 5 mAh, 5000 mAh cell, that means 16 watt hour is the energy of that cell. If I divide 16 by 1000, okay, then this, sorry. So if I divide this 16 divide by the weight of that what we can say, cell. So suppose the weight of that is 100 grams, for example. Okay. So 100 grams means 0.01 gram, 0.01 kg, right? So 1600 this is watt hour per kg is the energy capacity of that cell. Correct. So in that manner, you can calculate the energy density of any cell. Now self-discharge. This advantage of the lithium-ion batteries are self-discharge. So what is happening? For example, in lead acid battery, if you keep the lead acid battery unusable, suppose you are at home and for 15, 20 days or for 1 month, you are going out station. Okay. Then if you are having a lead acid battery, if you keep it and when you come back after 1 month, you will be seeing the battery get completely discharged. Okay, so self-discharge rates are very higher in other chemistries of the cell, but in lithium-ion battery, the self-discharge rates are very lower. Okay, and that's why this, more beneficial for our vehicle application. Otherwise, what will happen? Suppose, for example, for 1 month you went anywhere. Okay, out of station you went, and your vehicle is for 1 month is standing in the parking, and now once you come, then your vehicle is not running, the battery is not getting on. Why? Because it get complete discharge. Now what we will be doing? We will not be having any option, right? Then again you have to charge your vehicle, and might be in that period of time your battery will get dead, right? So self discharge rates in lithium ion batteries are very low. Okay. Third is cell voltage. The cell voltage of a lithium-ion batteries are on around 3.6 volts or 3.2 volts. Okay, it range between 3.2 volt to 3.6 volt. In other chemistries of the cell, it is 1.2 volt or 2 volt, like that. So whenever this lower voltage is there in the cell, then to make a battery pack, you need higher number of cells, right? If you are higher voltage in a cell, then you need lower number of cells, right? To make a battery pack. That's why lithium-ion batteries are posing a higher voltage. Then to make a battery pack, to design a battery pack, we need lesser number of lithium-ion cell compared to other chemistry of the cell. Okay, so that is the third major advantage of this thing. Load characteristics. In lead acid battery or in other chemistries of the battery, the load, this voltage fluctuations are very high. Fluctuation in the sense ki whenever it is full charge, then some voltage will be showing. In nominal charge, it will be some other voltage will be showing, and in lower, like when it is only 10% charge or 5% charge, at that time some other voltage will be there. So this range of voltage are very high in other chemistries of the cell. But in lithium ion battery, this range of the voltage are very short. For example, I have a NMC chemistry, lithium nickel manganese cobalt chemistry is there. in lithium ion cell, then what will be happening? The maximum volt is 4.2 volt, and the nominal volt is 3.6 volt, and the lowest voltage is 2.8 volt. So the voltage range is from 2.8 volt to 4.2 volt. But in that what will be happening? The maximum of the time, 80% of the charge time, the voltage will be 3.2 volt. Okay, and that is called load characteristics. Okay, so the maximum of the time it will be a constant voltage, that will be 3.2 or 3.6 volt, and that is the load characteristic. In other, what will be happening in the other chemistries of the cell, this sometimes it would be, for example, lead acid battery, sometimes it would be 14 volt, sometimes it would be 12 volt, sometimes it will be 11, 10, like that. These fluctuations are very high. Okay, as you are discharging your battery pack. Okay, as you are discharging your cell. So this is the fourth major advantage of the lithium ion battery. Fifth advantage is no requirement of priming. What is priming? I hope you remember in initial days, like 5 years back or 10 years back, when we purchase a mobile phone, okay, then usually what we used to do, first time we used to complete discharge, okay, our mobile, and then we used to charge it again. Okay, people used to say ki if you do in that way, then your battery will run on a longer time. You remember this thing? Anyone have done this? Does anyone have done this earlier? Okay, self-discharge of battery depends upon which parameter. So see, participants, I will request you. So I will not be able to see the messages while I am presenting. So if you have any question, you can ask. So self-discharge depending upon chemistry of the chemistry of the cell. If it is it depends upon different chemistries. Okay. So if you are having NMC chemistry, like LFP, whatever lithium ion chemistries are there, in that the self discharge rates are lower. In other chemistries like nickel cadmium or this lead acid, in those all chemistries, the self discharge rates are higher. Okay. So I was talking about fifth point, no requirement for priming. So as I told you, so in initial days when we used to buy a mobile phone, we have like we usually do the complete, first time we complete discharge the mobile. The complete discharging of mobile means complete discharge of the battery. Correct. So we complete discharge the battery and then charge it again for a, so that it can give us a longer run time. Like it the life cycle should be higher. So priming is a process in which whenever we have a battery, we do some controlled charge and discharge process. Okay, we do some predefined charge and discharge process, and that's called priming. Okay, that is not required in lithium ion batteries. In lithium ion batteries, whenever it comes to you from the factory, it is ready to use. You can just directly use in your appliances, in your vehicle, in your anything. Okay, so you could be able to use it directly. There is no priming requirement is there. Okay, that is the other benefit of the lithium ion battery. Then variety of types available. Lithium ion batteries are available in variety of types. It could be circular, it could be rectangular, it could be in terms of pouch. Different varieties are available, right? And that is the other advantage of the this lithium ion batteries. Okay. So these all were the advantages of the lithium ion battery. Now, when we are going to design a battery pack, I told you that first we will be selecting a cell. Okay, first thing we have to do to select a cell, and what parameter we will be selecting a cell. That is the point of discussion. Okay, so I have mentioned these 8 parameters on which we will be selecting a cell for our battery design application for our battery design purpose. Correct? So everyone is sync with me? Hello?
Yes, sir.
Everyone is sync with me? Anyone is facing any issue like I'm not able to understand, or the I'm speaking too much fast? Anything is there? Or
This
language
is
issue?
Pawan. Hello.
Yes.
This is Pawan. Can you explain the battery pack voltage and if for example, I have 1.3 kilowatt hour battery. So
Okay.
how it is defined and those things, is it depends on number of cells or how it is? Can you
Yeah,
explain
yeah.
me?
Yes, yes.
Yeah,
I will come to that point. I have a
excuse me, Sajan sir. Hello,
yes,
am I audible?
yes, yes.
See, what we'll do, we'll take question answer at the end of the session. So let us first complete, then we'll take together, okay?
Correct, correct, correct. So
Otherwise, it
participant,
will create disturbance.
yes, yes, sir. So participant, actually, what we have
Okay.
done, we already, have different slides for each and every topic. So better we go each and every slide, and at last, because whatever question you have asked, we already have a particular slide for that. Okay, okay. So first thing we have to do, we have to choose a cell for a battery pack design. So what we will be looking for a like a particular thing, what speciality should be there. For example, if you go to buy a bike, okay, for example, if you go to buy a bike in any showroom, you might have different choices. Everyone is having different opinion. Someone is looking for cruiser bike, someone is looking for a sports bike, someone is looking for mileage based bike, someone is looking for performance based bike. So each and everyone having a different opinions. If each and everyone having different set of parameters. Similarly, if we are going to design a battery pack, then we have different parameters. On that parameter, first we will choose a cell, and then on that basis of that cell, we will be designing our battery pack. So we have listed these 8 parameters: high specific energy, high specific power, affordable price, long life, safety, wide opening range, toxicity, and fast charging. These 8 things should be there. What is high specific energy density? High specific energy, as I already discussed this high energy density. The same thing is high specific energy. So in your cell, the cell should be having as much as high in energy. Okay, the cell should be having a high energy. That is the first parameter. If you are having lower energy, then more number of cells will be required. Then the weight of the vehicle will automatically get increased. Then again the range of the vehicle automatically get decreased. Correct. The higher the energy density of the cell, the smaller the battery pack will be there, the lighter the vehicle will be there, and the more range we will be getting in a smaller battery pack. Okay, this is the first things we have to take care of whenever we are designing a battery pack. Second, high specific power. The power of the cell should be high, right? So power, when this power help us in, like suppose for example you have to give a quick race to your vehicle. At that time you need a high power. To high power means at what maximum rate we can extract the energy from the battery. That is high specific power. Affordable price, the price should be cost effective. In Indian market, each and everything is cost sensitive, right? In our mindset is, if it is cheap, then only I will be buying. Not for everyone, but maximum of the people in our country, they looks for the affordable price, because maximum of our population is, either they are middle class people, or either they are lower middle class people. So they always talks about price, right? Whenever you have to, in a vegetable market, if you go, in 2 rupees there is a this makes a difference, right? So this, in this one, in electric vehicle, the cost differences are like 50,000, 1 lakh, 2 lakhs, like that. So you have to choose a cell which are cost sensitive, which are affordable, right? Long life. You have to choose a cell whose life is long. Okay, so you might be you might be heard about that key. Whenever you are going to buy a electric vehicle, they gives you some warranty on your battery, like 5 years of warranty or 6 years of warranty or 4 years of warranty, like that. Okay, so what is that? That in their as per their design, this is the life of their battery. Okay, that should be higher. Okay, it should not like in 2 3 years your battery will get completely, the health of the battery completely get degraded. It should not like that. They should run for a longer run, right? Safety, we should choose a cell which are safe. Okay, this is very important point. Why? The lithium ion batteries are very sensitive. They are very sensitive to heat. They are very sensitive to high or high, overcharge. Overcharge. They are very sensitive to over discharge. They are very sensitive to mechanical, rupture or mechanical impact. Okay, these cells are very sensitive. So you should choose a cell which are safe, which are not that much sensitive. See, there is a jerk, then it get explode. It should not be there, right? So you should sell very widely in terms of safety as well. Wide opening range. Wide opening range means this, you know, the cell voltage should be lower, like 3.2 volt is the what is there, the nominal volt. Then the maximum volt and the minimum volt, these all things should be in a particular range, right? Toxicity. What is toxicity? The even though the lithium ion cells are not that much of toxic, right? But few materials are there in lithium ion cell which are little bit toxic, right? So what is happening, whenever your battery completes their life cycle, then you have to follow the protocol. There is a protocol for the lithium ion batteries ki once it get used, then there's a process to recycle the this lithium ion batteries. Okay, so even though they are not toxic, but few components are there in few materials are there in lithium ion cells which are toxic. So that's why we have to choose your cells very widely, right? Then fast charging. What is fast charging? Fast charging, nowadays whenever we talks about electric vehicle, then everyone asks a question ki how long it will take to charge. Okay, because normally the electric vehicles takes 7 8 or 9 hours. I am talking about electric car, so they takes about 7 to 9 hours, 7 to 10 hours to charge themselves, right? So now we are talking about fast charging, so it should get fast charge, it should not take that much of time, right? So not each and every lithium ion cells are not made up of fast charging. So you have to choose a cell if you are going to fast charge your vehicle. If you are planning to fast charge your vehicle, then you have to choose a cell which are made for fast charging. Each and every cell, each and every chemistry of the cell are not made for the fast charge. Okay, so these parameters are there on which you will be choosing your cell. Clear, everyone?
Yes, sir.
Okay, so I told you here variety of types of available in advantages of lithium ion battery pack. I talked about variety of types available. So what variety of types? So these all are variety of types are available. Available. If you remember for the torch, you are having only cylindrical battery packs. Cylindrical cells were there, right? But in lithium ion battery, we have cylindrical cells are there. We have option for prismatic cells options are there. These are our prismatic cells. Then we have pouch cell options are there, right? So variety of options are available. Clear? So these all three are lithium ion cells are there only. Form factor is different. One is cylindrical, one is prismatic, and one is pouch. Only form factor is different. Okay. So this variety of types are available, and these three, mechanical forms or of the form factor of the cell are mostly used in the electric vehicle application. Clear?
Yes, sir.
Okay. So moving next, just a moment. Okay. So now, so once you choose your cell, once you have selected your cell, then you have to do some calculation to get a particular kilowatt hour of the battery pack. Suppose you have to design a 2 kilowatt hour battery pack or 5 kilowatt hour battery pack, 10 kilowatt hour battery pack. Okay, so to design that, you required number of cells, and that number of cells should be in particular series and parallel combination. Okay, and if you done that parallel and series combination, then you will be getting a this complete battery pack. Okay, so this one I will be, for this one I will be opening my notepad, and then I will be telling you. Correct. So my notepad is visual to everyone. Correct. My screen is visible to everyone.
Yes, sir.
Yes, sir.
Okay, so I'm choosing a cell. Suppose, for example, I'm choosing 21700 NMC cell. Okay, so in cylindrical cell, I told you there are three form factors: cylindrical, pouch, and prismatic cells are there. In cylindrical cell, there are various, 18650, 21700, and 4680. These three cylindrical cells are majorly used in the electric vehicle application. 18650 means 18 mm diameter and 65 mm height. 21700 means 21 mm diameter and 70 mm height. 4680 means 46 mm diameter and 80 mm height. Clear, everyone? So I am choosing 21700 NMC chemistry. NMC means nickel, manganese, and cobalt. This is also a lithium ion battery pack, lithium ion cell. Okay. Now, suppose, for example, that cell is having a voltage. I'm taking the nominal voltage. Okay. See, the voltage is 3.6 volt, and the capacity, the energy capacity is 5 Ah. Okay. For example, then, and I have to make a battery pack. Okay. Which is having, suppose, for example, 48 volt system I have to design. Okay. So this is the cell, this is the cell capacity we have. On the basis of that, we have to make a battery pack. So in battery pack, different voltage systems are there. Lower voltage battery pack and higher voltage battery packs are there. If the DC voltage is lower than 60 volt, then it comes in the category of lower voltage. If the DC volt is higher than 60 volt, then it comes in the higher voltage category. This clear? Okay. So I'm taking a 48 voltage system. So I have to make a battery pack of 48 volt. Clear? And the capacity should be 2 kilowatt hour. Okay, 2 kilowatt hour. 2 kilowatt hour means 2000 watt hour. Clear? And then just a moment. And suppose the battery age capacity is 40 age, for example, 40 age battery we have to make. Okay. So these things are there. Okay. We have to make a battery pack which is having a 40 volt 48 volt system, the current capacity should be 48, and the overall energy capacity should be 2 kilowatt hour or 2000 watt hour. Okay. Now we have to on the basis of this, we have to do a calculation of number of cells in parallel and number of cells in series. Okay. So usually we tell as a n mp and ns. So m number of cells will be in parallel and n number of cells will be in series. Okay. So to get a number of cells in series, so we have total 48 volt system, right? So number of cells in series, sorry, in series required equal to total voltage 48 volt divide by this one cell voltage. One cell voltage is 3.6 volt, correct? So it will be giving me just a moment. So 48 divided by 3.6, it would be 13.33, correct? So 13.33 cells I can't take, right? 13.33 cells would not be possible. So I will be taking 14 cells in series. Cells in series. Clear? Then number of cell in parallel required equal to current capacity, that is 40H divided by what is the capacity of one cell, 5H divided by 5. It will be giving me 8, correct? So this much of cells in parallel. Okay. So number of cells required in series is what is happening. So if you multiply the number of cells in series to their voltages, that will be giving you overall voltage of the cell, overall voltage of the battery pack. And number of cells which are in parallel, sorry, number of cells which are in parallel, if you multiply the number of cells in parallel into the capacity of one cell, then it will be giving you a battery level current capacity. And if you multiply the number of cells in series into the nominal voltage of the one cell, then it will be giving you the overall voltage of the cell. So I have done the reverse of that. So I am requiring a 48 volt system. So 48 divided by the one cell voltage, then this number of cells I required in the series. So this is not a whole number. So I will be choosing next to that, right? Similarly, the number of the battery pack energy capacity I required is 48. If I divide that by one cell capacity, then I will get the number of cells in parallel, correct? And 8 cells are required in parallel. Okay. So now just 14 number of cells are there in series into 3.6. Okay. So 50.4, the overall voltage is there. Okay. Just so voltage is 50.4. So what is happening? If 48 volt system is required, then exactly 48 volt, calculation will not be possible. So whatever next is there, like near about that we will take, right? Because for example, 13.33 cells are required, but 13.33 number of cell will not be possible. So better to go for a higher side. Higher side means you will be having little extra energy, right? So voltage is 50.4 and current is, this is battery level. So current is 8 into 5, 48. Now, if you multiply the battery pack voltage and battery pack current capacity, then it will give you a battery energy capacity. Battery energy equal to voltage into current capacity. Okay. So 50.4 into 40, this will give you the this battery pack capacity. If I do this, 50.4 is already there into 40.
సరే ఉంటాను రా. నా అకౌంట్ లో 1500 1500 ఈరోజు డేట్ అయింది దాంది.
2016 watt hour is there. Okay, this is 2.016 kilowatt hour. So this is more and less near to 2 kilowatt hour. You all get clear about this?
Yes, sir.
This is clear. Now someone was asking how to define this, how we get this kilowatt hour of battery pack, what it does mean. So now it is clear to him, right? Hello.
Sir, can you explain me again?
Yes,
I have
sir.
some doubt.
Okay, so just forget about this. I am taking another example. Okay, this is a small battery pack. Now suppose we are going for a higher voltage. Same cell should be there. Okay, now this battery pack should be 3.350 volt. Okay, for example, 350 volt, and just a moment. And 200 Ah. Okay, 200 Ah. Okay, I have to make a battery pack, a bigger battery pack. This is a bigger battery pack for car application and all. So this battery pack should be 350 volt, and the battery pack energy, this current capacity should be 200 Ah. So I told you the number of cells required in series. In series, it would be total voltage. 350 volt is there, correct? 350 volt divide by what is the voltage of one, sorry, it should be V volt. What should be the voltage of one cell? What is the voltage of one cell? That is 3.6, right? So 350 divided by 3.6, that many of number of cells is required in series. Clear? So 350. So this is total this voltage of the battery pack system, and this is voltage of one cell. So in that battery pack, how many number of cells will be in series? That will be 350 divided by 3.6. That means 97.22. 97.22. I will be taking 98. Okay, because 97.2 number of cells is not possible. In parallel, what will be happening? 200 Ah is required. 200 divided by 5. Okay, 200 divided by 5. It would be 200 divided by 5. It would be 40 number of cells in parallel. Okay. So I have 40P, 40P and 98S. This is called parallel and series combination of the battery pack. 40P and 98S is this particular combination of the battery pack. Correct. And if I multiply all those 40 number of cells in parallel into 5, 200 Ah, correct? 200 Ah, and similarly, this 98 number of cells are in series. So 98 into 3.6 is the 352.8 volt. 352.8 volt. And if I multiply the battery level, this is battery level current capacity and battery level voltage capacity. If I define the battery level current and current capacity, sorry, if I multiply the battery level current capacity and battery level voltage, then it will give me a battery pack energy capacity, that is 70,560. 70,560 watt hour, and that means 70.560 kilowatt hour. Clear, everyone?
Yes, sir. Yeah.
Okay. So we are moving next. Just So this is parallel and series combination of the battery pack. So you have to choose any cell, either it is cylindrical cell, either it is prismatic cell, and then what you have to do, you have to make a combination of parallel and series. Then it will be forming a module.
For an epic house cleaning and storage. Again, are you ready? Do you have the book already and accountable?
So the number of cells in parallel combinedly called a module, and then each module will get connected in series, and then we will be having a final battery pack. Okay. So this was the basic calculation of the battery pack. Now moving forward, stages of battery pack design. Okay, stage of battery pack design. Just a moment. Okay. So what are stages of battery pack design? Cell configuration. Then we have to think about a structure. Then we have to think about the safety of the battery pack. Then we have to think about control of the battery pack. And then we have to think about the application interface of the battery pack. Correct? So first is cell configuration. Cell configuration we already have done. In cell configuration means series and parallel combination of the battery pack. And that comes from MP&NS theory. Correct? This we already have done. Okay. Now comes to the structure. Okay. So what do you mean by the structure? So whenever I speak about the structure, anyone have any idea when I talk about this structure of the battery pack, then what does this mean? Okay, no problem. So what is happening? Once we define the this cell configuration, then it comes second is structure. So the battery pack is used in the your vehicle. It is either the car, either the bike, either three-wheeler, or the bus. Any application could be there, and in that we have to integrate that battery pack. And since it is carrying the passenger, it is moving onto the road. So there are various compliances are there from the government, and we have to fulfill that. And in order to fulfill that compliances, we our battery pack should be structurally enough, it should be safe, it should be controllable, and it should be follow a particular predefined application. Okay. So first, whenever we are talking about structure, so in what are the structural part of the battery pack? If I talk about the structural part of the battery pack, it is casing is there, cover is there, end plates are there, some tying things are there, sail holder could be there, base plate could be there. So it depends upon designer. Okay, it depends upon designer how he designing a battery pack. So depending upon the concept of his design, he will be using different components to make a battery pack, and that components, that battery pack should be strong enough. It should be structurally, it should be strong enough to withstand to run onto the road. Clear? This is the mechanical part of the structure. This is the mechanical structural part. Then electrical. In electrical also, wire harness are there, bus bars are there, fuse will be there, plugs will be there. So I told you, like for example, just a moment. So in this one, we have choose one cell, then we have make a module. This is if it is a prismatic cell, then this kind of module will be there. If it is a cylindrical cell, then this kind of module will be there. Then these module means these all are in parallel. Here also module means these all are in parallel. Then each module get connected by each other by series. Here also these four modules connected by each other by series. But how they have connected? Some bus bar on top of the cell terminal, on top of the cell terminal, some bus bar should be there, some wire harness would be there to connect those all cells, right? Automatically it will not be connected. So bus bars will be required. Wire harness are required to connect each module by series. Then fuse for safety purpose, fuse and plugs are required. Correct? So this is electrical part of electrical structural part. Correct? Then some thermal structural part will be there. Cooling jackets will be there, or cooling plates will be there, or cooling tubes will be there. Safety valves will be there, or thermistors and all will be there. So I will be talking about each component and what is their use cases, like case, cover, end plate, tie rod, sail holder, base plate. These all are to hold the sail. Okay, these all used to hold the sail. Mechanically it is strong enough, rigid enough to withstand any impact, any load. Okay, so that is the purpose of the this mechanical parts, mechanical structure part. And electrical structure part, bus bar, it used to connect cells to make a parallel and series combination. The thermal structural part, like cooling jackets or cooling plate would be there, cooling tubes will be there. This is for to heat the battery pack or to cool the battery pack. See, thermal management of the battery pack is required, because these batteries are very sensitive to heat and all. So for that we do this thermal management and all. Otherwise, what will be happening? Thermal runaway could be happen. Thermal runaway, in the recently in last 2 3 years in news you might be read about that ki this vehicle got fire, this vehicle got fire. These all the major reason behind that could be the thermal management. So thermal management not only means to cool down the battery pack. Thermal management is also talks about heating up the battery pack. So what is happening? These cells, the battery pack, their optimum working temperature is 15 degree to 35 degree. Okay, so if it goes beyond that, then cooling is required. It goes beyond lesser than that, lesser than 15 degree, then heating is required. Okay, so both heating and cooling both are required depending upon the situation, depending upon the application, depending upon the topology where you are. For example, if you are on near to pole, like some European countries, some American countries, some in Canada, then most of the time heating is required. If you are in some Asian countries, some countries who are near about equilateral. Okay, so in those all countries, cooling is required. It also depends upon, for example, this weather. Suppose this is summer season, then obviously cooling will be required. If it is winter season, then in India itself, in winter season in north, you can see the temperature goes around 5 degrees, 6 degree, 10 degrees. In those all situation, in those all time, this heating is required. Okay, so that's why this cooling, this thermal structural parts are required. Safety, your battery should be safe. How it should be safe? It should be safe from vibration. It should be safe from shock. It should be safe from abuse, shock abuse. It should be safe from crash. Suppose your vehicle is running onto the road. So obviously road is not 100% perfectly plain. Okay, there are some ambiguities in onto the roads are there, and due to that vibration happens in your vehicle. And your battery design, your battery pack should be in such a manner, it should design in such a way it could withstand all that vibrations. Correct? Now shock abuse, suppose for example suddenly a huge bump comes onto the road, or you have to take a strong sudden brake you have to apply. At that time what will be happening? A shock will be applied on that vehicle, and whatever components inside that vehicle is there, either it is human being, either it is a human being, or there are some mechanical, electrical, any kind of components are there inside the vehicle. Each and everything which is inside the vehicle, which is integrated with the vehicle, that will face the same shock, right? So your battery should be strong enough to withstand that shock abuse, right? Crash. Suppose by chance your vehicle got an accident. Okay, so obviously crash and all will be happening. Due to that crash, it should not impact your battery pack. Because what will be happening in lithium ion battery, if you puncture the battery, if you puncture the cell, if you crash the cell, then explosion will happen. Okay, if you are having a very high shock, then it could tear down the battery, it could tear down the cell, and again explosion could be happen. Okay, so for that your vehicle should be, your battery pack should be designed in such a way this battery pack which should withstand the vibration, the shock abuse, and the crash. Okay, for that reason different materials we have to use, different you know structural features we have to add onto the battery pack casing, pack cover, battery pack structural part. Those all things we have to talk about material, we have to think about their features, how it should be, right, to withstand those all things. Then in electrical, what safety requirements are there? So this is the safety requirement from mechanical side. Then again electrical side, some safety requirements should be there, like short circuit. It should, like, short circuits never ever should be happen. And if by chance any short circuit happen, then it should not affect the passengers who are inside the vehicle. Okay, so you have to design the electrical system in such a way that the short circuit could not be happen. And if the short circuit happens, then immediately it should recognize the short circuit, and it should cut off the battery from the rest of the vehicle. It should isolate the battery from rest of the vehicle. And for that reason, various device like MSD, manual service disconnect, or isometers are there. Those all equipments we use, right? Then overcharge and over discharge. Okay, your battery, in general, in battery there's a BMS, battery management system. It never ever allows overcharge and over discharge. But by chance it happens, by chance it get happen, then the battery should be designed in such a way it should be safe. Okay, if by chance overcharge happen or over discharge happen, the electrical design of the battery packs should be in such a way it should be safe for the passenger. Then the thermal safety in terms of thermal. Suppose by chance the battery get heats up. So usually what happen, if the temperature of the cell, if the temperature of the battery goes beyond 120 degrees Celsius, goes beyond 150 degrees Celsius, then thermal runaway could be happen. Thermal runaway is a exothermic process in which cell gets explode and in which high amount of heat. Okay, so thermal runaway could be happen. For that reason, we have to design a battery pack thermally in such a way that even though usually it should not happen, never ever it should be happen, but suppose by chance it get happen, then the passenger inside the vehicle should be safe from that. This battery should not explode. Okay, so those all design if the thermal runaway happens itself, the battery should not explode, the thermal runaway should not propagate. Propagation means suppose one cell get damaged, one cell get in thermal runaway condition, then it should not propagate to other cells, right? So that design consideration we have to think about. Clear? Then control. So what in control? In control, whenever I talk about battery pack control, then vibration control and hardware robustness should be there. Okay, so vibration we already spoke about that. The hardware robustness. What is hardware robustness? So in battery pack, apart from this cells, we have harness, and apart from cells harness, we have bus bar, and apart from cell harness and bus bar, we have a battery management system. Okay, and other electronics components are there. So those electronic components we call as a hardware. So those should be designed in such a way they should be very robust. It should not like uh, running onto the road, some vibration and all happen, and the components of the hardware start getting off. It should not be happen. It should be designed in such a way, right? Then we have a electrical control. For electrical control, we have a cell monitoring system and BMS. Okay, so what is BMS? Battery management system. This battery management system, if I say in a layman language, then this battery management system is the brain of a battery pack. Okay, for example, in computer, we call CPU as a brain of the computer. Similarly, in battery pack, the BMS, we say BMS as a brain of the battery pack. Clear? So the battery management system continuously monitors the battery pack. Okay. Similarly, this each and every cells, each and every cell should be connected through some sensing devices and all, so that continuous monitoring of each and every cell should be there, and this battery management system would be controlling over there, right? So there are few functionalities of the battery management system. First is to monitor the cell level voltage, to monitor the pack level current, then to monitor the temperature of the battery pack. Okay, so these three, four things they used to monitor. Apart from monitoring, it continuously, it continuously check the state of charge of the battery pack. It continuously checking the state of discharge of the battery pack. It continuously checking the state of health of the battery pack. Okay, then in also the BMS, the main one, you know, the we can say function of the BMS is to balance the cell. Okay, so what is happening? Cells are like chemical things. Okay, so 2, 3, 5, n number of cells are there in series and parallel. So what will be happening? These cells are based on chemistry. So while running, while charging or discharging, some cells could be charged or discharged some faster rate. Some cells it could be charged and discharged on lower rate. Okay, so due to this reason, some imbalance happen. Okay, imbalance happen between the cells. So the BMS also balance those cells. Okay, there are two types of battery management system. One is active balancing battery management system, and one is passive balancing battery management system. In passive balancing, what is happening? This the cell which is are at higher energy state, that higher energy state cell, the BMS is to discharge, to equalize, to maintain the charge balance. Okay, that is called passive balancing. In active balancing system, what is happening? The same the BMS from the higher charge state cell, it transfer the energy from higher rate of charge cell to the lower charge state cells, and that is called active balancing system. Okay, so this is the major electrical control parameter of the battery pack. Then application. There are two major application into the battery pack: interface and telemetry. Interface means how you communicate the battery pack. For example, what is happening? You have a computer. Okay, give me a moment. So you have a computer, and you opens your computer, you opens up your laptop, or you have a mobile phone, you opens up your mobile phone. Okay, and you switch it on. Then there is a interface comes into you, right? Whatever seeing on your screen, whatever you visualizing on your screen, that is a interface. Clear? So how this interface came? Might be some Android systems are there, some Windows system would be there. So those all things able to makes you enable to interact with your device. Correct? Am I clear? So this interface enables you to interact you with the device. Similarly, in battery pack also, it should be able to interact with you. Like if you are a engineer, if you are an technician, if you are a service engineer, you you should able to read the state of the battery pack. Okay, and for that a particular interface is required. In battery, normally generally in the battery pack application, we use the CAN communications. Okay, so from CAN communication we can interact with the battery. Okay, so CAN will be giving you some signals, like voltage signals, some current signals, many things would be there. And depending upon that, you can actually read your battery packs, correct? So that is the interface. Telemetry should be there, so that where is my battery, where is my vehicle? Okay, this telematic system should be there. So this is the stage of the battery pack design. I hope I made you clear. I was able to give you an idea about these different stages of the battery pack design. I hope I was able to deliver this. Correct?
Yes, sir.
Yes. Okay. So moving ahead. So major components of a battery pack. Okay. So although we know about the major components of the battery pack, but in this I will be telling you the functionalities, like what these components do. Okay. So we have cell, we have electrical connectors, we have thermal interface material, we have battery management system, we have contactor, we have housing, we have cold plates or tube, we have communication systems, we have adhesives, we have gaskets, we have thermistors, we have insulation pads, we have a wire harness and encapsulant. These all are major components of a battery pack. Cells, we already know key cells used to give us the energy, correct? The electrical connectors, or we can say the bus bar. Okay, so this bus bar or the electrical connectors help us to collect the energy from each cell to the to supply it to the vehicle, correct, via a battery management system. Then we have a thermal interface material. Thermal interface material is a thermal material which help us to gather the heat from the cell and dissipate to the housing. Like the generally the housing of the battery pack is made up of the metallic metals. Okay. And the metals are good conductors of heat, correct? So the thermal interface material which is inside the battery pack takes the heat from the cells and transfer it to the housing, so that this thermal balance should be there. Battery management system, I already discussed about the what is battery management system. It controls the battery pack, it monitors the battery pack, correct. Contactor system, so although we have a battery management system in our battery pack, so this battery management system is completely electronically controlled, a hardware based device, correct. This contactor is a somewhat mechanical switching device which help us to switch the battery switch on and switch off, switch it off. Okay. So suppose sometimes anything happen in your battery pack and your hardware gets failed, the battery management system gets failed. Okay. Then in contactor, some parameters already feed. Suppose for example, you have used 200 amperes of contactor. This is something similar to the fuse in our home in our home we have fuse, right? So what that fuse do? To suppose the current it goes higher than that, then it fuse automatically with switch it off, right? Similarly, in battery pack, we have a contactor. So suppose this hardware and all mechanical, this electronic thing get failed, then there is a rating. Like for example, I have 100 amperes of the current rating of the contactor. So if the current flowing through the contactor is beyond 100 degrees, 100 ampere, then contactor will switch it off. Okay, and it will disconnect the battery from the rest of the vehicle. So this is the contactor system. We have a housing. The housing is a outer structure in which this all the battery components, all the battery module have been inbuilt. Okay, cold plates or cold tubes. As I told you, in electric vehicle in battery pack, we have to design a thermal management as well, and for that we will need some cooling plates, some cooling tubes will be required. Communication systems, as I told you, the interface, the CAN communication system that is required to interact between you and your battery pack. Adhesive, inside the battery pack, adhesive plays a very important role. Okay, nowadays the majorly the most of the battery packs are designed on the adhesive base. So inside the battery pack, the contact, this integration of cell to the cell holder, or two cell holder, or this other mechanical components and on all are there. Those all, you know this mm, stick together with the help of adhesive. Piyush Agarwal have been raised the hand. Please let me know. Yes, please. Piyush.
Sir.
Yes, yes.
Sir, would you please repeat about the adhesives?
This contactor.
Adhesives, sir.
Sorry, adhesive. Yeah, yeah. I'm
Ah,
speaking about the adhesive. See, in general, adhesive glue is there, right? We have a glue, right?
yes, sir.
Suppose you have to stick a paper, you use the glue, right? So glue is some layman language. In industrial terms, we say it as a adhesive.
Okay, sir.
Understood? Glue is a layman
Yes, sir.
language. In industrial term, in industrial terminology, automotive application, the glue we told as a adhesive. So adhesive is to, whenever you have to stick two components, suppose there is a bus cell holder, and in between cell holder we have to put the cell. So first we apply some adhesive, first we apply some glue, and then stick the cell. Correct? So adhesive is the industrial term for the glue. Gaskets.
Okay, sir.
Each and every battery pack, in each and every battery pack should be IP67 rated. At least it should be IP67 rated. This is the industrial compliance. This is the industrial government compliance is there, right? To make the IP67, whenever there is a two adjoining surface, there we use a gasket. Okay, so I'm just going back to the battery pack, adhesive and gasket. I will be letting you in more detail. So this one. So for example, this plate is there, and this plate is sitting on this flange, correct? This plate is sitting on this flange. So now what will be happening? Suppose I am tightening it. I am integrating this plate with this with a nut and bolts. Okay. So nut and bolts will be holding this in a very tight manner. It will be mechanically, it will be very strong enough, right? But still there will be a gap, and in between that gap air could ingress inside that, water could ingress inside that, and water should not ingress inside the battery pack. And for that reason, IP67 is required. And to make a battery pack IP67, before applying the nut and bolt on this complete line in complete flange, we apply some gasket. And there are various kinds of gasket. Ready-made gaskets are there. Ready-to-use gaskets are there, form in place gaskets are there. So various types of gaskets are there. We apply those gaskets here and then put this top plate onto that and then tighten with the nut and bolt so that there should not be any gap between these two interface so that water should not go inside. Understood my point? So just a moment. So suppose this is there. So on complete this, okay, on complete this, a gasket would be there. On top of that we will be putting so that there will not be any gap and water should not be going inside. Okay, so that is the use of the gaskets. Okay, similarly the adhesives. So inside this module, this is a module, and inside this module n number of cells are there, and those cells have been placed inside a cell holder. And those cell holders, how they will be holding the cell, it will be fluctuating, right? So it should not happen. So we apply the adhesive, then stick the cells inside that. So that is the work. Apart from that, other applications are also there for the adhesive, but this is the one of the application of the adhesive in the battery pack. Clear? Then thermistors. I told you that thermal management of the battery pack is required. And to do the thermal management, either we have to cool down the battery pack or either we have to heat up the battery pack. Then how we will be doing that? So we should know the inside temperature of the battery pack. For that reason, in various position, we put few thermistor and which gives the input to the BMS. Okay. Now in this particular position, the temperature is this. In this particular position, temperature is this. And depending upon the temperature, this BMS decides to either to heat up the battery pack or either to cool down the battery pack. Clear? So that is thermistor. Then we have insulation pad. why insulation pads are required. So initially I was talking about some, whenever we were talking about the stages of battery pack design, we were talking about the safety, and in safety we were talking about vibration and shock safety. Then this electrical safety could be there. Okay, so for that we use insulation pad. So insulation pad not only gives us a, this just a moment. Okay, so the insulation pad provide a electrical insulation between two components. Okay, so whenever we design a battery pack, we provide say electrical insulation all around that, and then we packs with a housing. Okay, so that if by chance anything happen, this should be insulated from other metallic components of the vehicle, other metallic components of the battery pack, so that electrical insulation should be there. Wire harness is, once we collect all the charge, once we collect all the current from each and every cell, then we have a wire harness which carry the current to the motor to run your vehicle. Correct? And at last we have encapsulation. So as I told you in when I was talking about this stages of this battery pack design, I told you ki suppose in case one cell got exploded, one cell got some thermal runaway happened, then the heat of that should not reach to other. Okay, for that reason, between the voids of the cell, between the gaps, the between the two cells, there are gaps, right? In that gaps, we put the encapsulant, so that these encapsulants are thermally insulative, okay, and electrically also insulative, so that the heat of this cell should not reach to other cell. Okay, and that is the work of the encapsulants. Okay, now design consideration for a battery pack. So once we have we talked about these components of the battery pack, what design consideration for a battery pack should be there? Material selection. Okay, first we have the material selection. We can choose plastic, we can choose metal, but we have to think about like what component we have to design. Either we have to design a cell holder, either have to design a housing, either have to design a structural component. So depending upon the requirement, I will be choosing a material, correct? So generally, like I have to design a cell holder, then plastic I will be using. If I, in place of cell holder, like in place of plastic, if I use metal, what will be happening? The weight will get increased, right? So where the plastic is sufficient, then why I will be using the metal. Similarly, the outer housing generally should be metal. But if I use the plastic in place of metal, then what will be happening? The structural rigidity will get, I will lose my structural rigidity, right? So we have to very wide while selecting the material selection. Apart from that, what is the happening? Each and every component of the battery pack should be fire resistant, right? Ideally, each and every component of the battery pack should be fire retardant, fire resistant. So metal is always, obviously, if I talk about metal, they are fire retardant, they are fire resistant. But the plastic, generally plastics are not fire retardant, right? Generally plastic are not fire resistant, but we have to put some additives in the plastic so that it becomes the fire rated material. So always we have to choose fire rated plastic material for this our battery pack design application. Okay, cell holder design consideration for cell accommodation. Depending upon the cell, either I am going to the cylindrical cell, I'm going to the prismatic cell, I am going to this pouch cell. Depending upon the form factor of the cell, we have to think about the cell holder design. Normally, for example, if I have a cylindrical cell, so in cylindrical cells, what is happening? Those cylindrical cells, the outer casing of the cylindrical cell are made up of steel, so they don't used to shrink or expand. But the prismatic and pouch cell, their outer body is used to shrink and expand while charging and discharging. So for that reason, between two cells, we have to provide some gap, and in that gaps we have to put some pads, so that that pad can absorb this shrink and extension, right? So those are design consideration you have to think about whenever you are designing the cell holder. Thermal consideration, I already spoke about that, how thermal design is important for the electric vehicle application, and we have to think about the thermal consideration of the battery pack. Material cost optimization. Okay, there are n number of materials are available in plastic itself. Some lower cost materials are available, some medium cost, some higher cost materials are available. So you have to choose very widely. If I can, for example, just for example, for insulation, generally we use Nomex sheet. Okay, for example, Nomex sheets are there, and in Nomex sheet, the cost of the Nomex sheet depends upon the thickness of that. Okay, so suppose you are 20, for example, 50 micron Nomex sheets is there, the cost will be something different. And suppose 100 micron thickness of the Nomex sheet would be there. So more or less the cost will be double of that, right? So now suppose in 50 micron thickness, our work is sufficient, our design will be sufficient. Then why to use 100 micron, right? So in that manner, in that way, the material cost optimization we have to think about. Okay, structural integrity. The battery pack should be structurally strong enough to withstand all the vibration, all the shock, all the impact. It should be there, right? It should withstand all those things. We already spoke about that. Bus bar design. Okay, this is the very important thing. So our bus bar should be designed in such a way. Bus bar design means the thickness of the bus bar and the width of the bus bar, means cross section of the bus bar should be sufficient enough to carry the current, and it should not get heated up. Okay, so for each particular current requirement, there are some thumb rule ki, okay, this much of current is there. Then there are some basic calculations are there ki, okay, this much of current have to flow from the bus bar, then this much of thickness and this much of cross section should be there. Or else if we go for the lower, then what will be happening? The temperature of bus bar will be get rise, right? The temperature of bus bar will get rise, and once the temperature of the bus bar will get rise, then what will be happening? The battery overall temperature of the battery pack also get increasing, right? So that should not be ideal case. So we have to be very wise while selection of the material for the bus bar and the selection of this uh, cross section of the bus bar. Okay, apart from that, while choosing your bus bar, material selection of the bus bar is also very important. Like there are various, like nickel is there, then copper is there, then aluminum is there. So these three material, the nickel, copper, and aluminum, these three material mostly used, widely used in the battery pack bus bar application. But in this also, you have to be very cautious. Ki the bus bar, you have to connect the bus bar with the cell, right? And to connect the bus bar with the cell, various technologies are there. Like we have this uh, laser welding is there, wire bonding is there, resistance spot welding is there. So what process you are going to use, correct, for this connection of the cell and the bus bar, that process also makes you to define what material of the bus bar I have to use, correct? So that things you have to talk about. Okay, because what is happening, the sale of the material, sorry, the material of the sale is fixed. Like once you choose choose the sale, the outer body of the sale is fixed, right? Now you have to connect the bus bar to that material, correct? So there are different things, like for example spot welding. Okay, so in spot welding, and suppose you have a cylindrical cell, so cylindrical cell's outer body could be made up of nickel, or it could be made up of steel, right? So you have to choose that material which easily spot welded with that, right? So you have to be wise with that. If you are going for the laser welding application, then in laser welding application, what will be happening? These similar materials also could get welded. But what is happening? You have to very cautious that The diffusion in laser welding, what will be happening? The top of the material, the bus bar, gets melted up, it get diffused and goes inside the cell, okay, cell terminal. Okay, so this material should be easily get diffused. So those all a parameter you have to think about when you are selecting the material for the bus bar design. Correct. Packaging constraints. Whenever as an engineer, whenever we are going to design any product, anything, always packaging constraints are there. It should not like you have a, you design anything, you design any length, width and height, and you sell, you know, and now this battery pack have been designed and integrate into the vehicle. No, it should not be possible. So what is happening in vehicle? There are predefined space are there. Okay, in this space the battery pack should get fixed, and that is the mechanical constant, that is the packaging constant for you, right? So your battery pack should get fit into that. Okay, it should not like enormously any dimension you have made and now you will be telling you fit into that. No, it's not possible. So packaging constants is also there. Weight consideration, the battery pack weight is very important. The more the battery pack weight, it will directly impact onto the range of the electric vehicle. You know, in one charge, in one full charge, how many kilometers your vehicle could be run, that is the range of the vehicle. And that range depends upon weight of the vehicle. And in electric vehicle, major weight of the vehicle is contributed by the battery pack. So if the battery pack weight is higher, then obviously overall that vehicle weight will be the higher, and more the weight of the vehicle, then more energy will be required to run your vehicle, and more energy you will be depleting. Then you know, shorter in short term, in shortly your battery pack will get discharged, right? So the weight of the vehicle, the weight of the battery pack directly impacts on the this range of the battery pack. So that's why the weight consideration should be there. High voltage isolation, especially in car, especially in electric car, the battery packs are high voltage battery packs. Okay, so there is should be a isolation. Okay, I was talking about this insulation pad. Okay, this insulation pad, this is majorly used for isolation, and this is not only sufficient. Apart from this, isometers and all should be used to continuously monitor the isolation between the battery pack and the vehicle, or this isolation between the uh, this current collectors and the other components of the battery pack. Okay, ease of assembly and the service. Battery pack should be designed in such a way it should be easy to assemble and it should be easy to service. Okay, aesthetics. Automobile application, in automobile application, you know, not only in automobile application, whenever suppose you go to the market to buy anything, whenever you are going to purchase anything, first what you should you notice, look wise, it should looks good, right? It should look good, right? Similarly, battery should also looks good, and that's why the aesthetic comes into the picture. Okay, so these all design consideration for a battery pack you should think about. Okay, and last, once you design a battery pack, then you obviously you will be going to assemble the battery pack, you will be making a prototype, you will be doing the production of the battery pack. Once you do that, then before coming onto the road, before coming onto the market, you have to uh, pass through homologation process. Okay, homologation process is governed by some this government body. Okay, they test your vehicle, they test your battery pack. So in this one, they test your battery pack. It is it's whether it should be launched or not, whether it should be go for the customer or not. So for that, some homologation standards are there. In India, we have AIS standards are there, and in for battery, in those all standards like AIS standards is the automotive standards for our Indian market. But there are n number of AIS standards are there. In that, few standards are there specifically for the battery pack. Okay, for example, AIS 156 is there, AIS 048 is there, AIS 038 are there. So few standards are there which are majorly for battery pack testing and battery pack homologation. Okay, so in left side I have some homologation testing for L category vehicle. L category means light category vehicle, and in right side we have M and N category vehicles. Okay.
Sir,
Yes.
sir, L category vehicle means light category
Yeah.
vehicles. But
L category means
M and D,
yeah,
M and M category vehicles.
M and N are I'm coming to that. So M and N category vehicles are like your passenger cars and heavy duty vehicles. Okay. So those all are M and N category vehicles. Clear? So
Yes, sir.
cars usually comes in M category. This is a series L, M, N. It's not like light, medium, nothing like that. It's just alphabetical series are there, L, M, N. By chance, L means in light category, and M means this M in M category. All the passenger cars come, and the smaller light commercial vehicles comes. Okay, and in N category, the heavy duty vehicles like bus, trucks, and all those all comes in N category vehicle. So in L category vehicle, we have to pass the vibration test, the thermal shock and cycling test, mechanical drop test. The mechanical drop test for removal RES. RESS means rechargeable electrical energy storage system. Okay, rechargeable electrical energy storage system. Okay, so this is RESS. Fire resistance test is there, external short circuit protection is there, overcharge protection is there, overcharge discharge protection is there, over temperature protection is there, and hydrogen emission test are there. Similarly, in M and N category vehicle, apart from this test, we have mechanically integrity test is there, thermal propagation test is there, and over current protection is there. This is some, I guess, some older amendment of the AIS standard is there. Recently government came for the latest amendment as well, so this could be little bit different. Okay, but majorly this test we do. Okay, for this battery pack application, what we do the in vibration test. In vibration test there is a vibration table. On that we fix the battery pack, and at a particular G, like might be 8G, 10G, some standards are there. On, for example, for light category vehicle it's 8G. So on 8G we vibrates the battery pack, and after completing the test, it should not, you know, thermal runaway should not be there. It should not explode, or and in interface the SOC and SOS should be there. Okay, so after the completing the test, what is the pass and fail criteria? So no physical damage should be there. Okay, to the casing or other mechanical parts, no physical damage should be there, and none of the components should be no melting of the components should be there, no fire should be happen, no explosion could be happen. Okay, now, so this is the pass and fail criteria. Okay, thermal shock. In thermal shock, we keeps in a environmental chamber, and gives a very high intense heat, and do the test, and after completing the test we see whether the it have been passed or fail. Okay, so what is the pass and fail criteria? So for each test, for each this test, apart from there is a test called nail penetration test. Okay, so I will talk about that. So apart from nail penetration test, each test, the pass criteria is no physical damage to the casing or other component, no melting should be there, melting of components should not be there, no fire or no explosion could be there. Okay, mechanical drop test. In mechanical drop test, what will be happening? This is for removable battery pack. So in two-wheeler, mostly you see that the battery pack we can take it out and take it to home and charge it there, right? These possibilities are there. So for removable battery, there is a mechanical drop system in which we hold the battery at 1 meter height and drop it. Okay, so that is the mechanical drop test. Fire resistance test is there. So in fire resistance test, what will be happening? We hit up the battery by fire at a particular height, and it should not explode. It should not melt. It should. This is the passing criteria. It should not explode. Okay. Then again, external short circuit protection is the short circuit test we do. Overcharge protection, we forcefully we do the overcharge and see what is the happening. And again, the same pass fail criteria is there. Similarly, forcefully we do the over discharge. Okay, over temperature we do. And last one, a hydrogen emission test are there. Since this is a what we can say, this cells are there, and cells are majorly inside the cells, some chemical reactions are going on. So there is a hydrogen emission test are there. So that also should get passed. Okay, so this test we have to follow. Once we pass all those tests, then your battery pack is passed by the authority, and then you can use that battery pack for your this for your use cases. Okay, so that's all for the day from my side. I hope I was able to deliver you best of mine.
Sir, what is meant by hydrogen emission test?
Hydrogen emission test means in cells, since chemical reactions are going on, so obviously some gases are emitting, right? So there is a criteria ki your cell should not emit beyond this level. Okay, so that we check by, there are some sensing device and all is there, that sensing ki okay, in this particular time there is a limit set ki beyond this limit the emission should not be there. Okay,
Emission or leaking?
emission of gas, see, chemical reactions are going on. For example, lead acid battery, whenever you charge and discharge your battery, some gases it emits, right? Some gases comes out,
Yes,
right?
sir.
Similarly, in lithium ion cells are also there, since chemical reactions are going on. Whenever you are charging, whenever you are discharging, the inside the ions and cations are moving from this side to that side or that side to this side, right? So in that way, some gases will be emitting, right? So
Okay, sir. Okay, sir.
so for environmental consideration, there is a limit ki your battery pack should not emit the gases beyond this limit. Okay, depending upon the size of the battery pack.
What does REESS stand for in last slide?
Rechargeable electrical energy storage system.
Okay, thank you, sir.
So yeah,
Hello.
So
Sir,
now,
what are the complaints need to be followed for battery homologation?
so this compliant was for battery homologation itself. The last slide I showed you, that is the for the battery homologation one.
No, what are the conditions are there? Like
Okay.
which
For which?
IEC standards or ISO standards? What are all the things we need to follow? Or Indian government has any regulations? They have announced anything that we need to?
Yes. So in India, we have AIS standard, automotive Indian standards are there. So we have to fulfill the AIS standard to run any vehicle onto the road. In AIS standard, for the batteries, I told you already in this session, for the batteries, for L category vehicle, we have to follow AIS 156 standard. Okay. And for the heavy vehicle, for the passenger vehicle, we have AIS 038, AIS 048. These few standards are there for the battery specified, specifically for the battery. For the vehicle, different sets of standards are there, but for the battery, you have, for the light category of vehicle, you have to follow the AS15 standard, and for the M and N category of the battery pack, we have to follow this AIS 038, 048, and few other standards are there. But basically, if you have to launch your battery in India, you have to follow the AIS standard.
Thank you.
so if any other guys have any question, you can put in chat, or else you can directly ask. So meanwhile, sir, we have some question from YouTube also.
Yeah, please.
So the first question is, sir, in hybrid vehicle, you said there is no external charging,
Yes.
but it is that much effective by braking?
That much effective by?
Braking.
No. So in hybrid electric vehicle, what is see, there are two types of hybrid electric vehicle. One is hybrid electric vehicle and one is plug-in hybrid electric vehicle. In hybrid electric vehicle, they have made it as simpler. So there is only a small battery pack is there and a small motor is there. So that is, for ride assisting. That is not to full-fledged run your vehicle. The in hybrid electric vehicle, this electric vehicle system, whatever the motor and battery will be there, that will be small, and they will not be able to full-fledged run over there, right? They only assisting the IC engine. Okay, and since they are small, so this only regenerative braking system is sufficient enough to charge that. In plug-in hybrid electric vehicle, the batteries are larger, the motor is also big, so that full-fledged it can run on electric vehicle system itself. So you can get simply you can get 100, 120, 150 kilometer of range on the electric vehicle system on via this electric vehicle system, and that's why since the battery is bigger in plug-in hybrid electric vehicle, so this regenerative braking system will not be sufficient enough to charge the battery. That's why external charging system is there. So there are differences in a hybrid and plug-in hybrid electric vehicle. I hope I am clear.
So I hope Gana Prakash, we have answered you. And the next question is, which is this thermal interface material?
So thermal interface material is something like a pad or adhesive, okay, or glue. So they are a material which stick together. For example, just for example, I have a cell, right? So I show you in this slide, we have a module, and bottom of the module we have a this cooling plates are there, okay, or cooling tubes are there. So what will be happening to proper transfer of heat from cell to tube, cell to cooling tube, there should not be any gap, right? If there is a gap, then air resistance, air will be there, then we will not be able to transfer all the heat to the cooling tabs or cooling plates. Okay, so for that reason, between these two, we put some thermal adhesive. Thermal adhesive means those type of adhesive who are thermally conductive. Okay, thermal interface material are those type of material who are thermally conductive. Okay, so since we are putting this material between two components, between two interface, that's why we call thermal interface material. So those all are interface material which we keep between these two to connect together. And since this is a thermally conductive, that's why we call thermal interface material. I hope I am clear.
So Sanat, I hope we have answered your first question. His next question is, Nexigo battery are marketing their battery which is having plastic enclosure. Any comment on this, sir?
Yes. So I told you, it's not hard and fast. You have to make a metallic structure. In plastic itself, there are too many plastic types are there. There are very strong plastics also are there. Okay, in plastic itself, inside, you can play with some features. Whenever you are designing a plastic housing, you can provide some mechanical ribs are there. Okay, so if you go for the product design, if you go for the plastic design, you will be able to read it in plastic itself, how to strengthen that plastic. To strengthening the plastic, we provide some reeds, we provide some gusset, we provide some structural feature inside. Okay, so if you have a good space, okay, because to provide that ribs and all, each side 2-3 mm is required. In battery pack application, what is happening? 1 mm gap is matters. Okay, so you have ample amount of space, then you can provide some features for the structural integrity. In that case, plastic also will be sufficient enough. There is a no hard and fast rule. The only rule is that whatever material you have selected, you should pass the homologation criteria. I hope I am clear.
So Sanat, I hope we have answered your question. So
but one thing I wish to add, so that plastic you have seen, I don't know to which company you are talking about, but I am sure that will be for two-wheeler application, because they are having a small battery pack correct? In four-wheeler, when there is a big battery pack, big chances of impacts are there, then anyway, always people use the metal enclosure itself. I hope I am clear.
So this is the next question is from Shreyans Misra. He is asking like, sir, which type of electric vehicle we use in commercial purpose like PHEV or VEV, or which type of EV is more preferable between the three?
See, if it depends upon person to person. If you ask me, then I will say you the full electric vehicle should be used, because in hybrid electric vehicle what is happening, two combinations are there. Electrical is also there and mechanical IC engines are also there. So more the complex system, more chances of wear and tear, more maintenance, more weight. Okay, so in the end it is affecting to your cost as well. In the end it is affecting on your mileage of the vehicle as well, right? So I am especially prefer the full electric vehicle.
Okay, so I hope Shreyans we have answered your questions. If anybody other is having any question, you can put in chat. So meanwhile, we will take one more question from YouTube. Which is the thermal like difference and advantage of NMC and LFP?
Okay, so NMC is nickel, manganese, and cobalt. LFP is lithium this ferrous phosphate. Okay, this is the chemistry name. So NMC are having more energy density. Okay, so whenever we have to design anything, for example, as I told you, so between the outer housing, this either I have to select the metal or I either have to select the plastic. It's all depends upon the designer. Similar, and also it depends upon the application. Similarly, choosing the LFP and NMC, both are good in their way. NMC is good in higher energy density. LFP is good in safety. LFP is safer than this NMC chemistry. LFP is safer than in terms of thermal sensitiveness. Like if you talk about heat sensitivity, they are safer when this battery heats application and come together, then they are safer compared to NMC chemistry. So whenever you have to design a such type of application where high energy density is required, then obviously you will be going with NMC chemistry. And if you are going to design a application where obviously heat will be there, okay, and safety is more concerned, then you could choose the LFP application.
So yeah, and Sanath on YouTube is saying like you ask like which company? Yeah, that is Nexigo Energy, and yes, they use in two-wheeler only. Whatever
Yes.
you said.
Yes, yes.
So okay, Sanath, I hope we have answered you clearly. Thank you so much. So if anybody is having any other question, just let us know. Otherwise, we'll wind up. So meanwhile, we have some updates like we have got lots of requests like everybody need this video for revision purpose. So our team has decided on YouTube this video will be live for few days. So you can subscribe the channel and you can revise the session from there. Okay. And next is like very soon we'll be announcing our full course also, which is 1 month program. Okay. So there we used to discuss EV technology in depth, and the complete EV will be taken care by 3 experts working in 3 different domains of EV. Okay, so meanwhile we have other question also from Shreyans. Sir, as we know, the problem associated with EV nowadays is that they have long recharging time. So what we can do with this problem?
Okay, so what is happening, long charging time is a case, right? But nowadays what is happening, batteries are there who are capable to get the fast charge. Okay, who can be able to charge themselves in 30 minutes, 40 minutes, like that. So fast charging things is also there. So don't have to worry about that. Now the vehicle are sufficient enough to get them fast charge as well.
So I would
So
like to add.
this is not a long run. This was earlier it was happening. Now technology had been advanced. So this is not a long run. Yes, Sonu sir, please add.
Yeah, so I would like to add, being basically from R&D background, so our government and even in various IITs, NIs, lots of research work is going on, and even VNIT Nagpur is working on a huge project for fast charging applications. So I think this problem will be solved very soon. Any other question? So anybody want to say something, any feedback or anything else, whatever, if you want any new bootcamp on any topic you wish to, you can mention in the form which we have shared in chat section. We'll consider if the crowd is more. Okay, so yeah, so we have got another question. What factor depend on fast charging? On YouTube, Sanath is asking.
Okay, so fast charging are like vast factor depends on fast charging. So cells different chemistries are there, right? So not all the chemistries are capable of fast charging. There are few chemistries which could be fast charging. Okay, so basically the chemistry of the cell defines the fast charging capability of the cell. Mostly the power cells. Okay, the power cells are made up of for fast charging. So they can go up to 10C, they can go up to 5C. So though all are capable of, in 20 minutes you can be able to charge your vehicle. So chemistry defines the fast charging capability of a battery pack.
Yeah, perfect. And we have got lots of requests also for our long program, like which we used to run for 1 month, and daily we used to have 1 hour to 90-minute session in evening. Obviously after 7 p.m. because our experts are working professional. So for that you can check our website. The link has been already shared in your chat section. Okay. Meanwhile, we'll reach out to you in case of any other doubt and query you have. You can put in chat, or else you can put in feedback form. Our concerned team will connect with you. So I hope we can wind up now. So thank you all for attending this session. Thank you so much, Sajan sir, for this wonderful boot camp, and it was so knowledgeable and full of industrial contents. Thanks a lot.
Thank you very much.
Thank you, sir.
One request from my side, we all are connected on a WhatsApp group. So if you have any doubt, we can connect on. You can drop your message in WhatsApp group as well. We will try to answer you on that chat box itself.
Okay, that's great. Yeah.